Okay, so let's do a tank problem. So I'm just going to write down the problem. So you have a 100-gallon tank of salt water. Salt water. Initially 35 pounds of salt. At an initial concentration of 0.35 pounds of salt per gallon of water. And then the problem says concentration is lowered due to fresh water added at 2.5 gallons per minute. And tank is also drained at 2.5 gallons per minute. And it's considered well stirred, which is great. Okay, and then we are given that the rate of change to the concentration of salt in the tank is given as C, the concentration as a function of time, equals negative 0.025 per minute times C, function of t. See, this is actually C prime, so this is the rate of change of the concentration, equals negative 0.025 times C, where C of t equals concentration at time t. Okay, this gives the first order differential equation describing the salt content in the tank at any instant is C prime of t minus 0.025 per minute times C of t equals 0. And the question, finally, is determine how long it takes to reduce the salt concentration inside the tank to 0.5 pounds per gallon. So, find time for C of t to reach 0.05 pounds per gallon. That's the goal. Okay. So, I'm a little bit confused by this because I think that should be a different sign based off of other problems where there's been a sign error here. I wouldn't be surprised if there's another one. So this is just a logic check. This makes sense to me, meaning this equation, because C of t, concentration, is a positive quantity, and this is a negative quantity, which means the rate of change is negative, which is good, because we are only adding fresh water and we're taking out salty water. It is negative, which is good. And again, I just think that there might be a typo in the problem statement, so I'm checking that now. And then it says that the first order differential equation describing the concentration of salt in the tank at any instant is shown below, where time is in minutes. I'm pretty sure that this is supposed to be a plus. Because otherwise, you would just be saying C prime of t plus C prime of t equals 0, which is not true unless C prime of t equals 0, which would make this problem pointless. So I think that there was a typo, and that this is actually supposed to be the differential equation, which follows just by moving this term to this side. Okay. So we can just solve this equation. So let's say C of t is going to equal A times e to the b times t. That means C prime of t equals A times b times e to the bt, which then would mean, plug in, you would have A b e to the bt plus 0.025 per min times A e to the bt equals 0. Which then means that you can say B plus 0.025 per min equals 0, which means B would equal negative 0.025 per minute. Okay? And then A you can get from initial conditions. So let's go up here. So we'll just save space and start here. Continued. So we know that the concentration at time equals 0 is going to equal this. 0.35, which is going to equal A times e to the negative 0.025 times t. But t equals 0, so that is just going to equal A. So that means that our concentration at any time is equal to 0.35 pounds per gallon times e to the negative 0.025 per minute times t, where t is in minutes. Great. Okay. And now we can just say we don't want to find the time where concentration equals 0.05. So that is going to equal 0.35 times e to negative 0.025 t. Divide both sides by 0.35 is going to be 1/7 equals e to negative 0.025 times t. Take the natural log of both sides. You have 1/7 equals negative 0.025 times t. Excuse me. And this will, using a logarithm trick, because I don't have my calculator on me, would be negative ln of 7 equals negative 0.025 times t. And this, by the way, is 1/40th, so we can write ln of 7, and if you had a calculator, you could just plug this in. It's 1 divided by 40 times t. So how long is it going to take to reach a concentration of 0.05 pounds per gallon? What's going to happen at time equals 40 times ln of 7 minutes. And ln of, ln of 7, so e squared is something like 9, so ln of 7 should be roughly like, I don't know, 1.9 or something. So time should be like 76 minutes, something like this. I think the answer it gets like 76 to 78 minutes. So that is the answer.